This is the recording for Lesson 15, presented on the 29th or the 30th of March, starting on Chapter 6, where we go into right triangle trig. The question of the day: what is something you are proud of, something you've created that you are proud of? Take a minute to think about that. Again, if you're rewatching this video, we already had this discussion in class. In this chapter, we're going to talk about basic right triangle trig, find an angle given two sides. We're using the inverse, Pythagorean theorem, angle of depression, and angle of elevation. As we start to learn about trig, make sure all your work is shown. Until I tell you otherwise, always make sure your calculator that you're using is in degree mode. Make sure you provide both exact answers and the decimal approximation rounded to 4 decimal places. As we start looking at right triangle trig, remember that means we're going to have one right angle. Remember, we have lowercase letters for sides and capital letters for angles. So this would be angle A, or we're using a delta. Angle C is the right angle, and angle B, we have the beta. I've used Greek letters for these examples, but we could also use capital letters if we wanted. And that capital letter is always going to be across from the side using the lowercase letter. When you're looking at your relationship for sine of an angle, again, if we're standing at that angle, you look across and see the opposite side, and your sine ratio is opposite over hypotenuse. So sine of an angle is always opposite over hypotenuse, as represented on these two examples. Again, notice that the ratio changes depending on what angle you're standing at. Cosine from angle delta, again, is the adjacent side, which is B, touches you, over C, the hypotenuse. So your ratio for cosine, as you may remember it, is adjacent over hypotenuse. Tangent is your third ratio. And again, when you look at that ratio for tangent, it is opposite over adjacent. When we are solving trig, there are three places our variable can be. Either we are solving for the numerator, solving for the denominator, or solving for the angle. It does not matter if this is a sine, cosine, or tangent ratio. Those are the only three places your variable can be. So there's only one way to solve each of these. Just like we've been talking about all year, anytime we see a fraction, your first step should always be to cross multiply. So on the first one, we have sine of 32 equals x over 23. We should start by multiplying both sides by 23. Now I do move that to the beginning just so it shows up as a coefficient and doesn't get confused with the sine of 32. At that point, we should be able to type that into our calculator using the decimal approximation to get 12.188. Again, you want to make sure your calculator is in degrees. For the second one, if our variable is in the denominator, as cosine of 56 equals 18 over x, just like before, we always have to start by multiplying across to clear that fraction. Then we're going to isolate the x. Right now it's being multiplied by cosine, so we're going to divide 18 by cosine 56. Remember, the cosine 56 go together. Cosine means nothing without that angle there. Now again, we can type this in our calculator to get the decimal approximation, which is 32.189. The third one, we're finding the angle. This is when we need to use our inverse. The way we can isolate that x is by taking inverse tangent of both sides. So when we take inverse tangent of the ratio, it frees up your x, showing you what angle would give you that ratio of 32 over 27. Again, I'm going to use that inverse button in my calculator, type that ratio in, and I get 40.855. If you did not get any of these answers, I would double check to make sure that your calculator is set in degrees. I would also not just take my word for it, but make sure you can use your technology that you're using, whether that's a graphing calculator or Desmos. When we are deciding what ratio we want to use, my suggestion is to always stand at the angle you're looking for or the angle you know. And it seems silly, but I usually draw myself at that angle that I am looking for or that I know. From there, I can see that the side across from me, which is labeled as X, is the opposite. I can see that the side adjacent to me that is the longest is across from the 90-degree angle, so that would be my hypotenuse. Once I've identified those sides, then I can say what ratio I would want to use. For this problem, if I'm solving for X, I'm going to have sine of 27 equals X, that's my opposite, over the hypotenuse. And again, just like we showed on that previous example, your first step is always going to be to cross multiply. That would be the exact value, and we can type that in the calculator to get the decimal approximation. Again, if we repeat that process on the second example, again, I'm drawing myself. That will help me identify my sides. The side across from me is my opposite side, never touches that angle, it's across from that angle. And then the X is marked as my adjacent. So the ratio that uses opposite and adjacent is tangent. So I'm going to say tangent of 39 degrees equals the opposite side, which is 23 over X. Just like on the previous example, my first step is always going to be to cross multiply. And now I want to solve for X. So I'm going to divide both sides by tangent of 39. Then I type that in my graphing calculator or Desmos to get the decimal approximation of 28.40. Again, I want to talk just a little bit more about using the inverse. For this one, I've labeled all three sides, so you do not have to use any one particular ratio. I wanted to show you that you could use any of these ratios depending on what side you have. So again, you always want to put yourself in the angle that you know or you're looking for. From that position, side labeled as 5 is your opposite, side labeled as 12 is your adjacent, and side longest is your hypotenuse. Your smallest side is always going to be across from your smallest angle. Your longest side is always going to be across from your largest angle. For this one, I have labeled all three sides, so you can choose which ratio you want to use. If I want to solve for X, I would say sine of X, let's say, is opposite over adjacent. If you want to use cosine for this one instead, you could say adjacent over hypotenuse. Now, as we showed on the first slide, the way we solve for X is we take the inverse of the ratio, and that will free up X so that we can solve for the angle. If we chose cosine, again, we're going to take the inverse of our ratio, type that in our graphing calculator in Desmos. Both of them, again, we're looking for that same angle, will give us 22.62 degrees. On the second example, again, I gave you all three sides so you could choose which ratio you wanted to use. I always draw myself in that position, and then I think about the side opposite, my adjacent side, and my hypotenuse, so that I can make the best decision as to what ratio to use. Again, all three sides are labeled here, so you can use any of your ratios. If you want to use cosine, you would say cosine of x equals adjacent over hypotenuse. If for this one you wanted to use tangent, your ratio for tangent is opposite over adjacent. Again, to be able to isolate that x, we need to take the inverse cosine of our ratio. That will undo that ratio and get x by itself. For the second one, again, we want to use inverse tangent this time of 7 over 24, and that will give us the appropriate value in the graphing calculator. We can also deal with story problems on these situations. I really encourage you guys to always draw a picture to represent the situation. That way we make sure we know what we're doing. So for this one, we're talking about a tree. So let's draw a tree. Again, your drawings don't have to be perfect. So it says a nursery plants a new tree and attaches a guide wire, which is a wire that helps hold it up straight in the wind, to a stake in the ground. So here's that stake in the ground. It says the guide wire is 8 feet long. So this red line we drew is 8 foot. It says that the guide wire makes an angle of elevation with the tree at 42 degrees. Find to the nearest tenth of the foot the height where that guide wire is attached to the tree. From this perspective, again, we have to look at what do we know and what are we solving for. So we can think about if we're standing here, we know the opposite side and the hypotenuse. The ratio that uses opposite and hypotenuse is sine. So we'll say sine of 42 equals opposite over hypotenuse. And again, we're solving for x. Your first step is going to be to cross multiply to get rid of that fraction. That is our exact value. And now we can type that in the calculator to get the approximate. It said to the nearest tenth of a foot. For this question, it's specified. So we're going to round 5.4 feet tall to the nearest tenth. Remember, you have to read the question carefully with that angle of elevation and draw your picture. Angle of depression is a little bit harder. Again, I strongly encourage you guys to reread the question as you're working on this. And again, draw out your pictures. So it says when flying home from Disneyland, we're going to make a very, very rustic airplane. Okay. You look down at the airport. So we're looking down at the airport. Now, remember that from the airplane, your line of sight is directly forward. If you look straight out the window, you see only blue sky. And if you look down at the airport, that's how far down towards the ground you are looking. That angle is 28 degrees. Again, it has to be from the perspective. You are up here in the plane. You look straight forward. You do not see the airport. You have to look down to see the airport. It says the pilot estimates that you are flying at an elevation of 1,100 feet. And it wants you to find the horizontal distance from the airport. Again, drawing that picture to scale, or not to scale, but drawing a picture is going to be really, really important here. So from here, from angle 28, I know the opposite side, and I know that I'm looking for the adjacent side. So that ratio is tangent. So I'm going to say tangent of 28 degrees equals the opposite side over the horizontal distance. That's the adjacent side. Again, always cross multiply first to get rid of your fraction. I'm solving for x, so I'm going to divide both sides by tangent of 28. Type that in the calculator. And again, we're going to round this one to the nearest tenth. So we got 2068.8. And let's get a unit here just so we complete the story problem. Okay. Again, super important you look at the perspective. Where am I? Where is my line of sight? And how far am I moving my head? That's the end of lesson 15.